So in this lesson, I will discuss how to solve a linear system of or a system of linear equations in two variables. Basically, what we shall do is when we are given two linear equations in two variables as x and y, well, the system does not have to be a system of two equations only. But we will begin with something, of course, that is simple. A linear equation in two variables, or two linear equations in two variables. So what we shall do here is we shall look for a pair of numbers x and y that makes the two linear equations true. So if you were to look at this only as an equation, let's say for example your equations like this are given or written on paper. So this is like figuring out what could be those pairs of numbers x and y that will satisfy both of these equations. But then again, you must remember that a linear equation also defines a line on your rectangular coordinate system. And so this pair or these coordinates, which is the coordinates of a point, if it is a solution to your linear systems, this point lie on both lines in your system. And so when that is true, that means it is the point of intersection of the lines. So basically solving for a system of linear equations in two variables means we shall look for the point of intersection. So how do you write a system of linear equations? So this is how you write it. Okay, so in math, we also aim for formality. Okay, so how do you write equations formally? This is how you do it. Okay, so you have the brace and you write the equations in standard form. Write each pair of linear equations as a system where the equations are written in standard form. So for letter A, the equations are not yet in standard form. Again, don't forget your brace. And then you write your equations in standard form. This one will become negative 6x plus y is equal to 5. This one will become 4x minus y is equal to 9. For letter B, again, look at that. It's going to be 6x plus y is equal to 11 and x plus 7y is equal to 9. Solution of a system of equations. A solution to a system of equations in two variables x and y is a set of ordered pairs x and y that makes all equations in the system true. Example number 2. Check if the ordered pair is a solution. Are these a solution to our linear system? Is 4, negative 1 a solution to our system? So what we do is we substitute it. Okay? So it becomes, okay, this becomes 2 times 4 minus negative 1. So that is equal to 8, okay, and then plus 1, okay. Minus negative 1 becomes plus 1. Hey, that's good. That's equal to 9. But you cannot stop there because if this is a solution, it must also satisfy the other equations in your system. Let us check it for the second equation. 4 times 4 plus 5 times negative 1, that is 16 minus 5, and that is equal to 11. It is not equal to 25. But in your system, the second equation must be equal to 25. So this one is not a solution. How about the pair 5 and 0? Is this a solution? 2 times 5 minus 0 is 10. That is not equal to 9. So right away, you know that this cannot be a solution. How about this? 5 and 1. Is this a solution to our system? Let's check it out. 2 times 5 minus 1 is 9. Okay, that's good. 4 times 5, that's 20, plus this is 5, it's equal to 25. And so this pair is or makes your equations true. That means it is a solution. One way to solve a system of linear equations is by graphical method. And so you know what you must do. You will sketch the graph and you will find the point of intersection. And that point of intersection would have coordinates x and y. So that means this x and y, because it is in the point of intersection of the two lines, that means this pair of coordinates satisfies both equations. So our first system is, okay, let us go back. So this is our first system, okay? By looking at it, it's not easy to see right away what is the solution. But what you can do is you can sketch the graph. It should not be complicated to sketch the graph, because all you have to do is to plot 2 points and draw a line through those 2 points. That would be one line. You will do the same for the second equation. And then you can just estimate the point of intersection, okay? So in this case, the point of intersection is this one. The solution is x is equal to 3 and y is equal to 2. Let us go to letter B. So your system contains these two equations. X minus y is equal to -1 and 3x minus y is equal to 5. You sketch the graph. Look for the point of intersection. That is the solution. The solution is x is equal to 3, this is x, and y is equal to 4. The next method is substitution. The name is telling you what you must do. You will write one variable in terms of the other and use this equation to produce one equation in one variable only. By using substitution method, you will start with a system of 2 equations in 2 variables, and then your goal is to come here to produce one equation only in one variable. So we will solve the previous problem, the problems presented under graphical method, and we will solve it using substitution method. So from letter A, you can see it there, x plus 2y is equal to 7. Well, that means that x is equal to -2y plus 7. And you will use this. You will use this in the second equation. The second equation is 3x minus 2y is equal to 5. You will replace x by this one, -2y plus 7. Okay, this is simple algebra, the distributive property of multiplication over addition, combining similar terms, and you get to here y is equal to 16 over 8, or y is equal to 2. So this is what I mean when I said that starting from a system of 2 equations into unknown, your goal is to produce one equation in one unknown only. Okay, so what do you do next? You already know y. We already know y. Y is equal to 2. So we will just use it in the other equation. Since y is equal to 2, we can go back to this one. Since y is equal to 2, this becomes -2 times 2 plus 7. And that is equal to 3. Our solution is x is equal to 3 and y is equal to 2. So be careful how you write it. This is an ordered pair, So our ordered pair is xy. The first coordinate is always x. The second is y. So this is how you write it, 3, 2. So sketching the two graphs, we already did this, and it matches the point of intersection when we solve this using graphical method. That is the point of intersection. Find the solution using substitution method. We shall go to letter B. From the first equation, x minus y is equal to -1. Okay, we can write x as x is equal to y minus 1. I am now going to use this in the second equation. I will replace x by y minus 1. That is why you call it substitution. And so doing that, okay, and simplifying our equation, we arrive at y is equal to 4. We already know y. Y is equal to 4. Okay? Since we know that x is equal to y minus 1, that means x is equal to 4 minus 1, which is equal to 3. And so this is our solution to the second system. And this matches the result when we did it by graphical method. Elimination method. The name itself is telling you already what you must do. You must eliminate. You must eliminate one equation, okay, from your system. But the direction is you must eliminate one equation so that, again, what you will produce is one equation in one variable. Find the solution using elimination method. Okay, so look at this. By adding the two equations, okay, you can visibly see that you can eliminate y right away because negative y plus y is 0. Okay, so you add the two equations. And so x plus 3x is 4x, negative y plus 4y is 0y or simply 0, and 7 plus 1 is equal to 8. Look at that, look at that. That is one equation, okay, one equation in one unknown only. 4x is equal to 8 or x is equal to 2. Now that we know that x is equal to 2, okay, coming from your first equation, this is 2. 2 minus y is equal to 7. So what is the value of y? Y is equal to 2 minus 7. And 2 minus 7 is equal to -5. So the solution to your system in letter A is this. These are the coordinates of your point, which is the point of intersection of your two lines. How about letter B? So here, by adding the two equations, you can eliminate x right away. And so this becomes 0. 2y plus -y is y. -1 plus -8 is -9. Y is equal to -9. Since we already know that y is equal to -9, we can use your second equation, okay? Replace y by -9. Look at that. 3x is equal to -8 minus 7. That is 17 or -17. And so x is equal to -17 over 3. So the solution to our system is this ordered pair. Okay, again, be careful with how you write the coordinates. The first coordinate is the value of x. That is x. And the second coordinate is the value of y. Find the solution using elimination method. Let us begin with letter A. Well, in letter A, by simply adding the two equations, we cannot eliminate any variable. Okay, we cannot do that. If we were to add the two, this one becomes 3x. This one becomes -y. Okay, and this one becomes 0. So you still have two unknowns, x and y. Okay, so it does not carry the intention of the method. The intention of the method is to eliminate one variable. What I will do is I will multiply, look at this. I will multiply -2 to equation 1. And if that is so, this becomes -2x. -2x plus 2x is 0. Of course, you must also multiply -2 to the other terms of your equation. Okay, we multiply -2. So why did this become -4y or -4y? Because -2 times 2y is -4y. -2 times -7 is +14. You add the two equations, okay, and the result is this. -7y is equal to 21, y is equal to -3. We now go to finding the value of x. We already know that y is equal to -3, so by substitution, x plus 2 times -3 should be equal to -7. And then by simplifying this is -6. X is equal to -7 plus 6. It is -1. This is the solution to our system. X is -1, y is -3.